Hello, and welcome to the video portion for the Equations Lab of ME 123, which covers global variables, equations, and configurations. Sometimes, the tools that we've already discussed can't fully enforce the designer's intent. You may want to ensure that a dimension remains equal across sketches and features, or you'd like to enforce a mathematical rule that states that one dimension is always twice another dimension. You may also have a collection of models that are all fairly similar but have different numerical values or feature suppression states. Equations, configurations, and global variables allow you to bake these rules into the model itself. Here, I have Steggy, who will be helping us today. To begin, the easiest way to work with the tools that we'll be introducing is to first reveal all of the dimensions that we used to make our model. This can be done by right-clicking on the Annotations folder and selecting Show Feature Dimensions. Okay, I know, everything's a little cluttered, so let's clean it up a bit. Just like when you're in a sketch, you can left-click drag on dimensions to move them around. SolidWorks doesn't do the best job at putting each dimension somewhere that you can see it, and sometimes they're hiding within your model. If you need to find a specific dimension, the fastest way to reveal it is often to left-click on the feature in the design tree, which puts little blue baubles next to the dimensions and makes them all pop out from the background for a moment. The more astute of you may have noticed that there are different colors across these dimensions. The black dimensions are linked to sketches, such as the side lengths of our rectangles, and the blue dimensions are linked to features, such as our extrude depth and the spacing of our pattern. If you want to change any of these dimensions, you can left-click on the number, and an editing box will pop up. While we're here, let's rename a few of these dimensions. It can be tricky to figure out which dimensions are connected to which features, and what each one does, so giving them useful names can really help make our model easier to work with. First off, we need to reveal the names of our dimensions. This can be done by going to the Hide Show options and selecting D1. Nice! We can see that SolidWorks has generated a list of very descriptive names for us to use. Let's change some of those to make them a bit more useful. For example, let's start with the tail lengths. The D2 isn't exactly the most helpful thing, so let's change it. You can do this by double-clicking on the dimensions value, and a pop-up box will appear. In the top input box, we can change the name to instead read tail lengths. The little @sketch7 tag is always going to be there, as it specifies which sketch the dimension is in. But at least now we have a better idea as to what the dimension actually does. While we're changing names, let's hit one more. If you single left-click on a dimensions leader, that dimension becomes active in the Property Manager, and here we can change the name from D1 to tail width. If you'd like, you can go through and rename all of the dimensions in your model, but oftentimes it's only worth renaming the ones that you intend on using. Okay, so what next? I talked a lot about enforcing numerical rules that link dimensions, so let's start there. I want the width and the depth of our head to always be equal. Due to the way that the head was modeled, we can see that the depth is a feature dimension, and the width is a sketch dimension, so we can't link them together via the standard equals relation. The first step is to find all the relevant dimensions, then we can right-click on one of them and select Link Values. This is the way to effectively create an equals relation between sketches and/or features. Let's see. I'll just call this one Head, and hit OK for now. We can see that it's created a little red chain link symbol next to the dimension, telling us that there's a little bit more to it than normal. Next up, we can right-click on the other dimension and select Link Values. From here, we can hit the drop-down and select Head, and then hit OK. Now, both of our dimensions have a little chain link next to them, meaning that if I were to modify one of them, let's say to 50, the other dimension follows suit. Of course, there's a way to sever the link if you no longer want it. You can right-click on either dimension and select Unlink Value from the context menu. Okay, what next? I want to ensure that the tail is always going to be twice as long as it is wide. To do this, we're going to need an equation. There are a few ways to create an equation. The first way is up in Tools, Equations, which pops up this handy table. If we already have a linked value, global variable, or equation set up, we can also access this table by right-clicking on the Equations folder and selecting Manage Equations. Finally, we can add an equation by double-clicking on the dimension we want to be driven by an equation, and then typing the equation into the input box. So, how do we write an equation? Using the box, we can start by typing equals, and then typing in the equation that we want. In this case, I want it to be twice the tail diameter, so we can type in 2 times, and then left-clicking the tail diameter dimension from the view window, which automatically adds in the tag for that dimension. Now, let's add in another equation through the pop-up menu. Once again, we can go through Tools, Equations, or we can right-click on the Equations folder and select Manage Equations. We can see the equation we just added right here, so we can make modifications to it if we want. And we can make new equations by left-clicking in the Add Equation box and then first selecting the dimension that you want to be driven by the equation. In this case, I want to modify the eye spacing. So we can find the diameter in the view window, and then left-click on that dimension to add it to our equations list. In this case, let's set the eye spacing to always be 1/4 of the head plus 1 millimeter. To do this, make sure that we have the correct box active. Then we can left-click on the head width, which automatically adds the equal sign, and then type in the rest. Divide by 4 plus 1 millimeter. There we go, nothing too complicated. Driven dimension on the left, driving dimensions on the right. You'll notice that I did specify units here, and that's for a good reason. If we were to ever change the units of our file, the equations may not take that into account. Suddenly, that 1 millimeter could be 1 inch, which would be entirely too large for the model that we have. While we're here, let's introduce a few new subjects. First off, comments. To the right of every equation and global variable, there is a comments box. Comments can be incredibly handy when you come back to a project after a long time away, and even more so for people working with your file for the first time. Try to do your best to give a descriptive comment whenever it's not obvious what a variable or equation does, in order to save the you in the future from trying to reverse engineer what it's supposed to do. Up at the top, we have a section for global variables. Let's take a look at them. In programming, a global variable allows you to change a number in one place and have that change affect multiple things, and it does pretty much the same thing here. For this class, global variables are always constants, meaning that they never rely on any other values or dimensions. If something references dimensions, it must be in the equation section. Let's create a global variable named plate dims and set it equal to 3 millimeters. Once again, if a value is going to be used directly, it's important that we specify units, in this case millimeters. If the value is going to be used as a ratio or as a multiplier for a value with units, we don't need to specify units. For example, if we want to use our global variable to specify how many times larger the height of the plate is than the width, then it's left unitless, as the value is multiplying a number that already has units. However, since we're going to say that the width is 4 times our global variable and the height is 10 times our global variable, neither of those values come with units, so the global variable is going to need its units specified. Now that we have our global variable, let's use it. Down in the equation section, we can create a new equation to set our plate's bottom width equal to our global variable picked from the drop-down, here plate dim, times 4. Then we can create the second equation, driving the height of the plate to be equal to our global variable plate dims times 10. Cool, now that we've got that, we can hit OK to apply our changes. Now, we can go back into our equations and modify the plate dims global variable to be 4 instead of 3. And when the model is rebuilt, we can see that the plates on the back of the model get updated to take this new information into account. Last little thing while we're here. Sometimes you might create a global variable or equation and later realize that it's not needed. To delete or disable an equation, you can right-click over here and select Delete to remove it permanently or Disable to get rid of it temporarily. So far we've covered equations, global variables, and linked values. Let's move to configurations. In SolidWorks, configurations allow you to have several variants of the same model stored within one file. This can be very convenient when you need to make changes to each variant simultaneously, and it allows you to have multiple different versions of the model all stored in the same place. Let's make a different configuration of this model. How about a tortoise? First off, we need to actually generate the configuration. This can be done in the Configurations Manager, the little cube tree tab that lives up above the design tree. You can right-click on the top portion and select Add Configuration. From here, we can pick a name, let's do tortoise, and a description if we would like, and then hit our checkbox. We can activate different configurations for viewing and editing by double-clicking on them from the Configurations Manager. You can also change the names by right-clicking on the configuration you want to modify and selecting Rename Tree Item. The first configuration is always named to default, which isn't exactly helpful, so let's change it to Steggy. There we go. So far, these two configurations are identical. Let's change that. First off, tortoises don't usually have these backplates, so let's get rid of those. Find the feature that you want to be gone for one of the configurations, and right-click on it, in this case Boss Extrude 3. From here, select Configure Feature. This allows you to pick the configurations that you want the feature to be suppressed in. Here, the tortoise configuration. When we hit OK, we can see that the plates get suppressed. But if we go back to the Stegosaurus configuration, we can see that the plates are still there. But wait a minute, all 3 of our plates are gone. Didn't we only suppress the first one? You see, the other 2 plates were created by this pattern feature, which is dependent upon Extrude 3, making it a child feature for the feature that we suppressed. As we discussed in the editing video, Child features can't exist without their parent features, so whenever a parent feature gets suppressed, all of its children features also get suppressed. This is one reason why you need to be careful about how you define your features. Any accidental parent-child relationships might end up disrupting how your configurations are set up. Alright, what other differences are there between stegosauruses and tortoises? This next kind of stubby. Let's stretch that out. First, we'll find the dimension that we want to modify. This one looks promising. You can right-click on it and select Configure Dimensions from the context menu. Tortoises usually have long necks, so let's set that to 100 and see how that looks. Okay, it looks like our mouth got left down at the bottom here, getting kind of a long face instead of a long neck feel out of this one. This is one of the reasons that design intent is important. When I first set up the model, the mouth has been dimensioned to the bottom of the head, which leaves it stuck there when we modify the configurations. In order to have the behavior that I want, we need to instead dimension the mouth to something else. If we go back into the sketch that was used to create the mouth feature, we can go about deleting this bottom dimension here, and instead dimensioning the top of the mouth to the eye line, since as we can tell from the configuration, the eyes are dimensioned to the top of the head. I want the eye to mouth distance to be the same across all of the configurations, so we'll leave this as it is now. And then we can set our value to 12. There we go, that looks about right. We can exit our sketch, and now if we check back in the previous configuration, we can see that the intended behavior is preserved. With our Stegosaurus configuration, we've got the stubby head and the plates, and on our tortoise configuration, we have the long neck and no plates. Next up, I think tortoises usually have shorter tails. Let's make a change to the tail length equation that we made earlier. Right-click on the Equations folder, and select Manage Equations. And then we can go to the tail length equation. While we're in the editing box, our configuration picker shows up. We only want to modify this configuration, so we'll select this configuration from the drop-down menu. And now instead of being 2 times the tail width, we'll modify it to instead read half of the tail width, giving us a stubbier tortoise tail. You can also use the same trick to modify a global variable across configurations, but I'll leave that to the astute viewer. Let's add a new feature to this model. How about a fillet to round the corners of its shell a bit? We can add a new feature just the same way that we normally would, but now once it's done, we need to make sure that we check the new feature's configurations to ensure that it's only unsuppressed in the configuration that we want it to be in. Generally, features that you create are suppressed in all non-active configurations, so you'll have to manually unsuppress them if you want them to affect additional configurations. Speaking of modifying features across configurations, we can actually do that for non-numerical values as well. Let's go back into Boss Extrude 2. But now while we're editing the feature, I want to change the ending condition from blind to midplane. Down at the bottom of the feature manager, we can then pick which configurations we want this change to be applied to. Here I'll just set it to this configuration. Awesome. Well, that looks like a tortoise to me. Now, before we get too excited, let's make sure that our Stegi configuration still works properly. With a properly configured model, you should be able to switch back and forth between the 2 configurations easily, although it may take a moment or two for more complex files. Last thing for this lab before I set you loose. Design tables. A design table allows you to quickly and easily see and modify features that change across configurations. You can even use the design table to add new configurations. This tool relies upon Microsoft Excel to function, so you need to have Excel installed on the same platform that you're running SolidWorks off of in order for this feature to function. When in doubt, the remote desktop server will always work if a personal install seems to be having difficulties. In order to make a design table, you first need to go to Insert, Tables, Design Table. I always leave these options at their defaults, and then we can hit the green checkbox to generate our table. This table holds the differences of the numbers and suppression states between our configurations. You'll notice that the end condition modification that we made to the head and neck isn't on here, but all of the numbers that we've changed across the configurations do show up. We can add new rows to make new configurations, such as the Stego tortoise, which has a neck that's 65 units long, fillets, and the back plates visible. We can also add new columns to add new features or dimensions that are modified across the configurations. You can memorize the codes and type them in, or you can select them from the view window. When starting out, I recommend using the design table as a way to double-check your work and modify configuration variables that already exist, as adding new variables can be tricky. But the option is there if you want to use it. When you're done with your design table, you can exit out of the pop-up window to save and close it. Any dimensions linked to the design table are turned pink in the view window. Finally, if we want to go back in and modify the design table once more, we can hit the drop-down under Tables, right-click Design Table, and select Edit Table to bring it back up. There, that about does it for equations, configurations, and design tables. These are very powerful tools that can really increase the flexibility of your models, but they do take a lot of practice to master. As always, experiment with your own models to see what you can do with these new skills, and ask questions as you get them. Best of luck, we will see you again next time.